Okay, welcome to lesson 9 of P1, topic 1, energy. And in this one, we're going to be talking about where do we get all our energy from? When I go over and I flick a switch for the light to come on, it never crosses my mind that that light isn't going to come on. And even if it didn't, I would assume there's something wrong with my house and not the national grid, which is where all our electricity is distributed. So, what are we using today? Well, today is a very cloudy day, last day of January, and so if we go to the National Grid live status, this will tell us where all of our energy is coming from. And as we can see, fossil fuels make up 46% of the energy right this second we're all using. Renewable energies are making up a quarter, 23%. Other types of energy are making up 19.7%, and then down in the corner here, these are all coming in from other countries, so about 11% of our energy. Now that changes on a day-to-day basis, and the National Grid's job is to balance all of these sources of energy to the demand that we are currently experiencing. So right now, lots of people are at home. The demand is coming from heating, turning on fires to make the house warm. And so given that there's not a lot of sun and there's not that much wind, actually a lot of our energy is coming from burning gas. And so today we're going to look at what are all these sources, what are their plus points, their benefits, and what are their disadvantages. So off we go. The title today is Energy Sources. The first thing we can say is we can split energy sources into two broad groups. Okay, so we're going to do them as a little table, like so. So in one group, we're going to have non-renewable. In the other, we're going to have renewable. So, pause the video, try and fill out, maybe do it in pencil or make yourself a little list at the back of your book. What sources did you see that were renewable and which ones were non-renewable? Pause now. Okay, and welcome back. So, non-renewable. The big ones are, I'm going to write fossil fuels. And then I'm going to go subheading. The major one is gas. The next one, oil. And the next one, coal. Those are the three main fossil fuels. They are all non-renewable. And we'll talk a bit more about what that means in a minute. Next, the major ones for the UK, definitely wind is number one. We are one of the windiest countries on the planet. Next, solar. That's made huge gains in the last 5 years. The price has gone right down. And in 2020, just last year, it finally became cheaper to generate 1 unit of electricity with solar than it was to generate with coal. So coal is on its way down. Solar and wind are most definitely on their way up. But there are a range of other technologies. We have geothermal. Geothermal. We have tidal, and we have wave. Then we have, and these kind of sometimes come under renewables, sometimes not, so I'm going to put others. Now the main one is nuclear energy and biofuels. Right, just checking in the book that I've covered everything. Oh, and I forgot one of the major ones. Hydroelectricity. Okay, so what we're going to do now is we're going to delve a little bit further into this list. So, what's the issue with non-renewables? So we're going to shrink everything so we've got some space to write. Like so, we'll put that up there. So, non-renewables, I'm going to put them in red. red for bad, like so. And I'm going to put renewable in green because they're good for the planet, like so. And these others I'm going to put in purple because I like purple. Right, so let's look at non-renewables. Okay, the main thing about non-renewables are they are finite. Finite. Once they have gone, there are no more. So once the coal's gone, once the oil and the gas have gone, there will be no more to burn. The other thing, and this is the biggest issue facing mankind at the moment, is they release a gas, CO2. And this is the most pressing thing for human race in the long term. Corona is an acute problem. It'll last 2, maybe 3 years. Releasing of CO2 is a 100-year problem. And so why is it a problem? Well, if we have the atmosphere and we have the Earth, the light from the sun passes through the atmosphere. It's why we have eyes, it's why we can see. The Earth then heats up. So if I use a red here, I can show the Earth heating up. When something's hot, it re-radiates the energy in a different wave called infrared. I'll put IR. We call it heat. It's what you feel when you put your hands out to a fire and you can feel the heat on your hands. That infrared cannot get through an atmosphere because the CO2 acts like a blanket. The more CO2, the more heat energy is trapped. So, releases CO2, which causes global warming. Causes global warming. And again, you think, well, I quite like it warm. Right now, I'm looking outside, it's about 4 degrees, it's raining. I'd quite like it if it was like the Mediterranean. However, across the entire planet, this will be a problem. Global warming will cause flooding. And already we're seeing extreme flooding events, the likes of which we haven't seen for 100 years. So Hale flooded last year where I live, Helston flooded this January. That will become more frequent. The other event, less likely to affect us, apart from up on the moorland, is fire. This year, well, in 2020, California and Australia experienced the largest fires they've ever had. And in an increasingly global warmed planet, those two events are going to happen more often. So that's non-renewable sources. They're fossil fuels that once they've gone, and they are trashing the planet. So that's those. So what is the future? Well, the future is renewable energies. Renewables. So let's have a little look at each one. If I go to my photo library, I've pre-downloaded some. So the first one, solar panels. Maybe you've even got them already. Fantastic technology. So solar cells, we'll call them. Now, the positives are they are free energy after buying them. So you've obviously got to pay to buy them in the first place, but once you've done that, they run free. There is no pollution. There is no CO2, which is fantastic. However, there are some downsides to this, and that is the sun is unreliable. Sun is unreliable in the UK. They will not provide enough energy for us, and particularly when it's darker and colder in the winter, when we need energy the most, they are not there for us. So that's our big issue there. Sun is unreliable in the UK. So that's our first one. Let's have a look at the next one. I'm going to put that under there so I've got some space to fit the next one. The next one is the one that Britain excels at. It's the one type of energy we've got lots of, and that's wind energy. So let's grab the picture of a wind turbine farm. Goonhilly was one of the first places in Britain to have one. And we also have one of the largest sets of wind turbines in Britain. So they were updated a few years ago and now they're huge. So they convert, so if I just put wind turbines, maybe draw a little sketch of each one, something like that. Draw the sun shining. There you go. Wind turbines, draw a little box, draw like a flower. So you could draw them coming out like that. 1, 2, 3, and then just draw the thing. There you go. Nothing fancy. Draw some arrows. Okay, so wind turbines. Again, they're not free energy after buying insofar as they do take maintenance, but wind is free. Wind is free and plentiful. Okay. Again, no CO2. No CO2. So that's fantastic. However, unreliable. And there's a couple of other issues here as well. Solar panels are great because you can put them in fields. They're flat. They don't make any noise. They don't move. You can put them on roofs. However, wind turbines do move. They are mechanical objects. So we end up with what's called visual pollution. They don't look great. Some people love them. Some people hate them. I'm pretty sure if you owned your dream home looking over the sea and the fields, and somebody then put a field of these in front of you, you wouldn't be happy either. Some of you may be even able to look out of your window and see them. Who knows? So, visual pollution. It's always a tricky one, finding where to put them that won't annoy people. Okay, so we've got unreliable and visual pollution. The next one, now we're getting more creative, so let's have a look at the next one. This one isn't very popular in the UK because the type of rock that we live on. So, this is called geothermal. Let's have a little look at this picture. Make it a bit bigger. Geothermal. Well, geo means the earth. Thermal means heat. And so what do? We pump cold water down into the rock. As you go down through rock, it gains 1 degree for every 100 meters. So if you can go down about 1,000 meters, a kilometer down, then you're getting a 10-degree change. So you can pump down cold water and it will come warm water. Then you can put it through a turbine and generate electricity. Now, we don't do this very much in the UK. There are a couple of places. One particular of note is Jubilee Pool in Penzance. It's a swimming pool heated by geothermal rock, but you need the right kind of geology for it to happen. Okay, so let's label this up. Geothermal. It's a free source of energy. Again, no CO2. Great. Downside, you need the right location. You can't just do this anywhere. Okay, and that's what's holding us back. Nearly all of Iceland is run on geothermal energy. Right, next one. One that we do have the potential to use a lot of, and that's wave. So, waves. We are surrounded. Cornwall in particular is almost an island. 80% of the coast is outward facing, and we have very little connecting us to the mainland. So, the sea is not something we lack. So let's have a look at how it works. In comes the incoming wave. You build a box over and you have a turbine here. And as the waves move up and down, the air inside is pushed in and out past the turbine. And that generates electricity. So, waves, we'll call it. Again, free source of energy, no CO2, and right location. You could have put these in London. So right location and maintenance. If you own a boat or you have anything to do with the ocean, you'll realise how corrosive the sea is. And so the maintenance of these can be quite problematic. So maintenance is a negative. No CO2. Great. And free source of energy, I'll just put the same as that, just draw an arrow. We're nearly finished. Let's look at the next one. Don't want that, I want photo library. Next, two of them. We're going to have that one and that one. So here, I've got a photograph of it for real, because it's been built and it's working. This is called a tidal barrage. Okay, so let me put the two near each other. Here we go, there and there. Let's zoom in and have a look. Okay, so what they've done is they've taken an estuary. An estuary is a section of land along the coast where the tide comes in and out each day. So I live in Hale. Hale is a tidal estuary. They've got to be the right type of estuary that has high water going through. And so what do? They block it by putting turbines in the way. And as the tide comes in, it spins the turbine. Then, 6 hours later, as the tide goes out, they do it again. So the water level rises up and down, and each time they collect the energy from the moving seawater. So this is called a tidal barrage. Okay, so this one, again, free sources of energy. No CO2. Detected a theme here. However, this one is tricky. You need cement to build. And cement needs cement, which has got loads, I'll put it as a bullet point, loads of CO2. So actually you have to make lots of CO2 to create something that later on won't produce CO2. So you need loads of CO2. You interfere with wildlife. So if you have spawning fish moving up and down the tidal estuary, that could be a real problem. So you interfere with wildlife. But on its plus side, it is very reliable, because you know exactly when the tide is coming in and going out. And I forgot to add that. We can add reliability. Reliable. I'm going to colour code these red and green in a minute. Red for good, red for bad, green for good. Waves, unreliable. Okay, last one. Biofuel. Now, biofuel is a kind of renewable, but kind of not, and we'll show you why. So, biology. What does bio mean? Well, bio means life. So if you study biology, you're studying the science of life. If you have biomass, then you're looking at plants, usually. Plants and waste. So, things we throw away that can burn, things that can be grown, those are biomass. And what we see here is, for example, this farmer is cutting down wheat. It's being processed and turned into a fuel, into sugars, and then converted into ethanol, and then used to make cars, planes, and lorries move. Now, nearly all of Brazil use this method. They don't burn petrol like we do. However, you think, well, look, they're all giving off carbon dioxide, just like my car does. However, the trick here, if we look, is to plant more trees, corn, wheat. And so they take in. So the aim of the game is to create a closed cycle of growing, which takes in the CO2, burning, which emits the CO2. And as long as you can at least grow as much as you burn, you should have a net zero increase in CO2. Okay, so we call it biofuel. Okay, we burn trees and sugar beet, which is what that one was, I've realised. So you burn sugar beet, but then the key to it is you grow more. Now, it's very reliable. We already have the infrastructure. We already have petrol stations. We already have tankers. So we have the infrastructure. We already have the infrastructure. However, it's time consuming. And it happened in Mexico quite recently. It drives up the cost of food. If you're a farmer and you've been used to making corn to sell for flour, and you haven't been making much money, if a petroleum company comes over to you and offers you 10 times the money to grow sugar beet, to then be turned into ethanol to burn for cars and for trucks, then you're going to take the money, which means the remaining growers of corn are going to charge more for their product. And so around the world we've been seeing riots and strikes against people who are using their land for biofuel. So it increases cost of food. So there are all the types. There's one more left which doesn't fit really into anything, and that's nuclear. And I'm going to do that separate. So how does nuclear work? Well, nuclear works by splitting an atom in half. And when it splits, it creates two smaller atoms, and it gives off lots of energy. Now, none of that creates CO2. So by splitting atoms to make energy, the plus is there is no CO2. It is tremendously reliable. But there is an issue. There's always a downside. And the downside is what is left over is extremely radioactive and dangerous to the human race. It will stay that way for several thousand years. So now the problem is, where do we put it out of harm's way? You could say shoot it into space, but it's too heavy. And if something happened to the rocket on the way up, it would all spray down upon us. So space is not an idea. So instead we need to bury it. We've dumped it in the oceans, in the Irish Sea in particular, which is not good. And we've buried it deep underground. But in 2,000 years, 3,000 years' time, who's to say that somebody won't come across that, not realising what it is and getting into trouble? So we have radioactive waste. A real issue. Where do we put it? Who wants it on their doorstep? The other issue is accidents. You may have seen or heard of Chernobyl. It's recently, last year, been turned into a TV series, which was amazing. Best bit of TV I've seen in a long time. Nuclear power stations can blow up. It's rare, but possible. And again, the consequences are dire. So that's nuclear energy. The UK isn't keen on it anymore. We have quite a few power stations. They cost several billions to build and equally the same amount of money to take apart and get rid of. So they're a real legacy of cost, when really now we could use a whole group of different renewables to get the job done. Okay, to finish off, I thought we'd have a quick look at one exam question. So here we have the householder has solar panels installed on the roof to heat water. The householder can also heat water in an immersion heater, which uses the mains. Give one advantage and one disadvantage of using a solar panel to heat water for the house compared to the immersion heater. So press pause, read the question, have a go, fill out a few sentences. If you're not sure, do it in the back of your book, and then I'll do the answer in a minute. Okay, let's have a little look. So, the immersion heater is always going to work. Solar panels, maybe not. So, the disadvantage is, we can say solar is unreliable. And what do we mean? Well, we mean the weather can change, but also nighttime. And so when do we use hot water? Well, we need quite a lot of it in the morning for our showers, washing our faces, that kind of thing. So nighttime, no energy. So that's the disadvantage. The advantage is cheaper electricity. Once you've paid for it, if you've paid, I don't know, £3,000 to have it installed, you never have to pay for that electricity. So cheaper electricity. We can have no CO2 emitted. Oh my gosh, I can't spell today. Emitted. There we go. No CO2, cheaper electricity. And I think that's it. Yeah, that'll do. You can stop now. Bye.